All right, now I'm going to take a look at finding the arc length of a given function either in a plane or in space. So the only difference here is if we're in a plane, we have two parts, two different functions that relate to it for the I and the j, and if we're in space, we'll have three. But ultimately, what we're going to be doing is taking the derivative of whatever our vector valued function is and then finding the magnitude of it. Then we integrate. So over here, problem number 102, the f of t is this t squared, and g of t will be 14t. We're only looking at something on a plane, and we're going from over the interval 0 to 7. So we're going to use that top formula. First of all, we have to find out what our r of t is, or r prime of t, excuse me. And that's just the derivative of each of those two components, which in this case is going to be 2t plus 14. Derivative of t squared is 2t, derivative of 14t is just 14. Now we want to find the magnitude of this. And we're going to take each of those two components, square them. And again, this will be an I and this will be a J, but what do we get here? So it looks like 4t squared, and then this one is 196. And we can simplify this further. Pull out a 4, so we'll get 2 on the outside. We've got t squared plus 49. So we're going to then have to integrate that. And you're going to use one of the integral functions that you learned in Calculus 2. And if you recall, if you're in a situation where you take the integral of u squared plus a squared, that's u over 2 with that same radical. And then a squared over 2 and the natural log of u plus, or u squared plus a squared under the radical. So we're in a situation here u is going to equal t and a will equal 7 since 49 is 7 squared. So let's try to solve for this. All right. So our surface area is equal to this integral. We've got that 2, so we can just pop that 2 out. Doesn't. This is what we're looking for. And we're going to leave the 2 out front. And we're going to just use the formula above. Whenever we see a u, we're going to plug in a t. Whenever we see an a, we're going to plug in a 7. So t over 2 squared plus 7 squared. I'm going to leave this alone. I'm not going to change that to 49 just for ease. We're going to be able to pull that right out. This whole thing is evaluated from 0 to 7. So what do we get? Our 2's are going to be able to cancel. So we'll cancel with the denominators over there. We get it to distribute nicely through there. So we won't worry about that. So at 7, we're going to have 7 squared plus 7 squared, 7 squared again. And then for the 0, our first bit will cancel because we've got a t multiplied by it, but the second half, we're looking at 7 squared ln of 7, excuse me, that's a 0. Plus just 7 squared into the radical. And we can pull out 49, or essentially 7, leaving 2 there. There's 2 7 squareds, so this will be 49 root 2. 7 squared is 49. And the same thing, this is 7 root 2. And what do we have here? 49 natural log of 7. All right. All right. No, that's necessary. All right. And I think that looks right now. All right, so I'm going to grab a calculator and see if we can solve this thing here. I'll enter the last one in a second. So first we have 49 times root 2. So we're looking at 69.3-ish. Next one, natural log, so 7 plus 7 root 2. I'm going to take the natural log of that, so natural log of our answer. All of that is multiplied by 49. So 138.5-ish. And finally, we're going to take the natural log of 7, multiply that by 49. So we get negative 95.3-ish. And let's just make sure we get this right. Those two, and then subtract another 95.3. About 112 and a half. So, give or take.